What is the next one we're going to do? Let's do 49. That was good enthusiasm back there. I liked it. Here we go. 49. Let's take a look. Oh, this is like my favorite problem. Okay, sweet. A small fish is dropped by a pelican that is rising steadily at 0.5 meters per second.
Is the fish okay?
So here's the thing, is everybody's like, whatever, that totally doesn't happen. My husband has a story that's related to this. He was playing in his backyard. He grew up in Davenport, Iowa, which is just on the Mississippi River. He was playing in the backyard with his dog. I don't know, they were playing fetch or something. All of a sudden, this huge fish falls from the sky, right? Like it's raining fish. And then, of course, his dog, this Siberian Husky, was like, yes! And then that was a really big mess. We're not going to get into that part. But fish do fall from the sky. He looked up, and there was a bald eagle that was flying, and it was looking really sad. Oh, I lost my lunch. So this really does happen. It's true. So let's solve the problem. Okay. A small fish is dropped by a pelican that's rising steadily at 0.5 meters per second. After 2.5 seconds, what is the velocity of the fish? And how far below the pelican is the fish after that time? Now, we're going to write down givens, but before we do that, I'm going to go ahead and draw a picture. I want you to draw the picture too, because I think that's going to help us to have a concept of what's going on. So, don't knock my pelican. If you don't like it, you can draw your own pelican. Just saying that preemptively because people make fun of my pelicans. That's the pelican, right? Thank you. That's what I thought.
Yes, it does.
And then there's my fish. Stop. And there's some water down here, we'll assume. Or no, maybe it's trees and a little child playing with his dog. Okay, there we go. All right, so there's the fish. The fish is going to fall, right? And the pelican is doing what?
Flying.
Flying, but is it flying horizontally or vertically? Vertically. So the pelican is going in this direction, and the fish is going to eventually fall down like that. Does that make sense? Let's write down some givens. How many objects do we have? Two. Let's talk about the pelican first. What do you know about the pelican? Raise your hand if you can tell me something about the pelican. A given from the problem. Take a look. Go.
V equals 0.50 meters per second.
Fantastic. Is the pelican accelerating? No, the pelican is not in free fall. That would be a lot scarier than the fish, right? Okay. The pelican is not in free fall. He is moving at a constant speed, so I'm going to just write down that the acceleration is equal to 0, just so we don't forget that. Okay. For the fish, what do you know? So Daniel's figured out the game, right? Whenever you're talking about a free fall problem, you can always write down acceleration equal to negative 9.8 meters per second squared. So he doesn't get to say that anymore. Somebody else has to tell me next time, okay? Just saying. What else?
VI equals 0.
Does VI equal, he said that with a question mark in his voice. What do you think?
I think VI equals 0.50.
Can you give us a convincing reason for that?
Because the pelican is holding it.
Right. So the I am the pelican. This is my fish. Hello, I'm a fish. Okay. So it's going up, and then it's going to go up and then down. If you think about it in a little bit more extreme example, so my hand is going to be the pelican. Woo! Right? It's going to go up and then down a little bit. Does that make sense? So now Ryan's going to say it with convincing.
VI equals 0.50 meters.
I believe you. Okay. In part A, what do they want to know and what else do you know? You know the time is, what was it, 2.5? And you want to know the final velocity. I'm not going to solve this problem for you, but what I want you to do right now is to look to see if you can find an equation that has these four things in it. Can you do that?
Yep.
Do that right now. Write down the equation. Check with your neighbors, see if they agree with you. Kayla, did you guys choose an equation? Which equation did you choose? That would be fabulous. Thank you. Uh-huh. Fantastic. How many other people chose that equation? Anybody else? Okay. Yeah? That didn't look super convincing. Or go ahead.
It was the first choice.
Okay. Okay. Do you understand why that's the best choice? Okay. Okay, I just want to make sure. All right. I'm going to move on from that from part A. Is that okay? For part B, how far below the pelican is the fish after 2.5 seconds? Now, this part is a little bit interesting. You need to find two things. What things do you need to find? The displacement.
Pelican.
But also, like, the displacement of the pelican and the fish and the net.
Does that make sense? Did you guys all catch what he said? And Max, you were kind of saying that too, right? Okay, so the fish is going to go down. And do you have an equation for the fish? The displacement of the fish? We know the initial velocity, we know the acceleration, we know the time. Take a look on your equation sheet, see if you can find an equation that has those four things in it. I bet you do. Tate, what did you find? What equation?
I had trouble with this one.
That's why I'm talking you through it right now. So you should be paying attention and doing what I'm telling you to do as opposed to just sitting there. Okay? So I just asked you, do you have an equation that has these four things in it? So take a look. I want you all to stay engaged with this right now. This is why I'm doing this. I've done these problems a million times. I don't need to do it for my own health. I know how to do them already. I'm here to help you. Check with your neighbors, see if you agree. Make sure that they agree with you. All right, so which equation did you choose, Tate?
Say the equation or the... I guess
Just say the equation for me.
Alright, change in x equals vi times change in t plus 1/2 acceleration times change in t squared.
Fantastic. Did you guys all agree with that? Yeah? Okay. So we're going to find that, and when you plug everything in, is this going to be a positive number or a negative number?
That's going to be a negative.
What do you say?
Because the fish is going down.
Yes. So this is going to be a negative number. You also need to find the displacement for the pelican. If we use the same equation, does anything go away? Is there anything that's equal to 0? The acceleration, which means the acceleration part goes away. So this whole thing is gone. So you're gonna multiply the velocity times time, right? Times the 2.5 seconds. Is this one gonna be positive or negative? Positive because he's going which way? Oh, you got it, you got it. So then when you add them together, you're actually going to add the negative of that one. You're going to make them both positive to find the total total distance between them. Is that okay? I'm going to pause this so you've got a moment to work on it, then we're going to move on.